Let's remember what you learned yesterday. Log base b of x times y. What is that the same as? Log base b of x log base b of x, what? Plus log base b of y. Because the log of a product is equal to the blank of the logs of the arguments. Sum. What about the next one? Log base b of x over y? What's that equal? So log base b of x minus log base b of y. Because the log of a quotient is equal to the difference of the logs of the arguments. So what about here? So you want me to bring the p down front as a multiplier? Is that what you're saying? So p log base b of x so the log of a number raised to the power is the same as the blank, the log of the argument. The log of the number raised to a power is the same as the power times the log of the argument. Now, the other two of these are going to take us back a couple days, so we have to think with our brain. God bless you. Log base b of b raised to the p. Well, we could do what we did here, right? Or we could remember what the rule is if the base and the base are the same. If the base and the base are the same, what's the answer? The exponent. What's the exponent? P. So log base 2 of 2 to the 6th equals x. What does x equal? 6. If the log base and the argument are the same, it's always equal to the power. Well, how is that any different here? Yeah, it's not. The base and the base are the same. What's the answer? The exponent, which is 1. Because anything to the 0 power is 1. There wouldn't be a b there, would there? Okay. So log base 2 of 2 equals x. What does x equal? 1. Now, this is something new for you today, and I kind of laugh teaching it to you. Okay? It's called the change of base property or the change of base formula. Why do I laugh teaching it to you? Well, first of all, it's super, super, super easy. Okay? Log of n divided by log of b. What's the base on these two logs? It's not written, so it's an understood 10, right? It's the common log. Well, here's the other reason why I laugh. We don't care about this. We don't have to care. We used to have to care because we used to have calculators that could only do log base 10 and log base e. That was it. Now, if I turn on my calculator and I press the log button, it automatically asks me, what base would you like to use? Sometimes it even's like, what base would you like to use, ma'am? Because it's so polite, right? I don't have to know the change of base formula anymore. Then why do I teach it to you? Because I have to. So I say, yes, sir. And now I'm teaching it to you, and now we're going to go on. Okay? Log base 4 of 32 is the same as log of 32 over log of 4. Just to make sure you understand what I'm saying, if I do log base 4 of 32, I get 2.5. But if I do log of 32 divided by log of 4, I also get 2.5. Do you see that they're the same? Okay? It's just not something that we're required to do anymore because of the calculators we have. Now, if you went to another school that had older calculators, you would definitely have to know this. Okay? This is not one of those times where we can get on our phone on the calculator and turn it sideways, right? Because on our phones, it'll only do natural log and log base 10. So what happens, there's those, I'll just say, older teachers that tell you, well, you won't always have a calculator with you. What do we say to that? Bullcrap. I mean, politely we say, yes, we will. Okay? But even then, will we always have a calculator that will do what we need it to do? This doesn't, right? So if we get somewhere we're doing our homework and all we have is our phone calculator, we do need to know change of base, don't we? So do we maybe care about it a little bit? Yeah, we should know it, right? We should know it, okay? What about this one? How would we rewrite that? Log of x plus 1 over log of 2. Everybody okay with that? So today, yesterday you just worked on this. I just worked on having you go from here to here, from here to here, from here to here, and then from here to here, here to here, here to here, right? So, well, today you get to learn the reason, okay? Today you get to learn that we're going to be able to solve some logarithmic equations because we know how to expand and condense, because we know how to use the product and the quotient of logarithms, okay? If we're going to solve a logarithmic equation, what we really, really, really want is the word log written only one time. Okay? Is there a way I can change this problem so that log is only written once? Yeah, I could condense this left side of the equation, right? Well, how could I rewrite it so that log was only written once? Log base 3 of what? What does this sign right here tell me to do to these two arguments? I know it seems like an addition sign, but what does that mean in logarithms? Multiply, right? So 9 times x plus 2 equals 4. Well, what is 9 times x plus 2? Now that we have written log only one time, we have a great opportunity. We have a great opportunity to learn or to use what we learned the other day when we went back and forth from logarithmic to exponential form, right? Remember how to do that? Can you rewrite this equation for me from logarithmic form into exponential form? Good, because I need you to be able to, right? What's the base of the log? Then that's the base of the exponent. What's the answer? Equals the argument, right? The base of the log is 3. That's the base of the exponent. What's the answer? That is the exponent equals the argument. You remember doing that? 3 of you? Excellent. Okay. Guys, is this an equation you know how to solve now? What is 3 to the 4th? 81. 81 equals 9x plus 18. What do you do now? Subtract 18. Hayden's so impatient with me. He's like, we've been doing this kind of equation since like 3rd grade. Okay, maybe not 3rd, Hayden, but maybe 9th, 8th, right? This is definitely something you've been doing for a long time, right? So 63 equals 9x. Dividing both sides by 9, x equals what? Is it right? Could I check by saying log base 3 of 9 plus log base 3? Oh no. This is what I hate about this part. I always press the wrong things in. Then put an arrow. Plus log base 3 of, I got a 7, so 7 plus 2 is 9, right? What should this equal when I hit enter? 4. Haha! It's right. So if something's in logarithmic form, I want to condense it so that I have log written one time, and then I want to write it in exponential form sometimes and go from there, right? Can I show you a time where you won't want to do exactly all of that stuff? Okay, how do we solve this problem? Let's do this one, number 3. What should I do first? Yeah, move the 4, right? I'm going to move the 4 up here as an exponent. So log base 9 of 3 to the 4th equals x. What is 3 to the 4th? So log base 9 of 81 equals x. Now when we got to this step on the problem before this, we wrote it in exponential form and then we solved it, right? Guys, where's the x? On the other side of the equal sign. Is this something I could plug straight into my calculator? Log base 9, whoops, that's not a 9, 9 of 81. Done. X equals 2. What would happen if I wrote it in exponential form? What would it look like? 9 to the x equals 81. Could we have figured out the answer that way? Yeah, we'd have to just use our brain, right? 9 to what power equals 81? Oh, 2. Okay, got it. Any questions? Is that the right answer? Are you positive? Could we be positive? 4 log base 9 of 3. Oh, I'm super positive now. Okay. What about number 5? So log base x of 2 to the 6th equals 2. What is 2 to the 6th? So log base x of 64 equals 2. Where's my x? In the base, right? If my x is in my base or in my argument, I really need to write it in exponential form, don't I? Okay. If my x is in my answer, like this one, I can just put that straight in the calculator and get an answer. Do you see that? Okay. But since my variable is in my base, I needed to write it in exponential form. What is this in exponential form? What's the base? That's the base. What's the answer? That's the exponent. What's the argument? Now we could do all the correct math here by square rooting both sides, but some of you could tell what the answer was just by looking at x squared equals 64, right? 8. Is that the right answer? We should, right? Okay. 6 log base 8 of 2. Yes. So if something's written in logarithmic form, what do I want to do first? I want to condense it so log is only written once, right? Now here log was only written once, but it wasn't in the most simplified form I could get it, right? So get it in the most simplified form. And then depending on where your x is, you might want to write it in exponential form or you might want to put it in the calculator. You okay with that? But what if it's not written in logarithmic form? What if it's written in exponential form? Like 3 to the x power equals 9. Well, I think probably most of you could look at that problem and tell me what the answer was, right? But thinking about how we solved this problem, because we've actually done this problem before. We've done a problem like this before. What we did is said we need to get the bases the same, right? And in our thought process, we did 3 to the x equals 3 squared. And if the bases are the same, then the exponent should also be the same. So x should equal 2, right? And that's the kinds of solving exponential equations that we did before, because that's really all we could do. Because what if we had a problem like this? 3 to the x power equals 8. Is there a way to rewrite this base for it to be a base of 3? I don't know what it is, right? We could do problems like this that we knew what the base was, that we could make a base of that number, but like this, we don't know. This is why we need logarithms. This is how we're going to use logarithms. We use logarithms to solve equations where the variable is in the exponent. So if it's in logarithmic form already, we wrote it in exponential form. What do you think we might do if it's already in exponential form? Yeah, might we try writing in logarithmic form? What does this look like in logarithmic form? Log base what? What's the base here? Then that's the base of the log. 8 is the argument, and the answer is the exponent. Guys, how do I solve that? Where's the x? Over here. How can I solve this? Calculator. Log base 3 of 8. Enter. Now, I'll just give you a heads up right now. You need to make sure you read the directions so you know how many decimal places to round to, yes? So x, what if I said thousandth? We'll just say thousandth for the examples. Is that okay? So 1.893. Done. Is it right? Ooh, I'm going to try to trick you. Is it right? 3 raised to the 1.893. That's supposed to be 8. So what did I do wrong? Yeah, I didn't do anything wrong, did I? What did I do right here? I rounded. So when I round as my answer, when I go to plug it back in, I just really need this number to be close to 8, right? Also remember this. If I want to say 3 to that power right there, I can actually go get it, highlight it, and press enter. Then that whole number's there, then it's going to be 8. Keep that in mind. Is that fair? Okay. 6 to the x power plus 5 equals 12. How do I solve that problem? 6 to the x power plus 5 equals 12. What should I do first? Nobody has any idea what I should do first? So have I taught you that before? So how did you instinctually know that you should subtract 5? Yeah, because you're not stupid, right? You're using prior knowledge when you're solving equations. You've got to get everything away from the x. Right now the x is in the exponent. We still need to get everything away from the x, don't we? 6 to the x equals 7. Is the base isolated now? Once the base is isolated, what do I want to do? Rewrite it in Logarithmic form. It's in exponential form right now. Try logarithmic form. Log base. What's the base up here? 6. So that's the base of log. Of 7 equals x. How would I solve that? Calculator. Log base 6 of 7, 1.086. 1.086. Now watch what happens this time when I plug it in. 6 raised to the 1.086 plus 5. That should equal 12. This time it was less than the answer it should have been, right? Because this time I didn't round, but there's still some more information after the decimal points. Does that make sense? Okay. But is it close to 12 like I need it to be? Yes. Okay. All right. Dun, dun, dun. Let's see if you can handle this one. There's like 3 ways I'm trying to trick you in this one problem. Okay. What should we do first? Plus 6. Be brave. Plus 6. That's exactly right. 3 times 4 to the 2x power equals 15. Now what? Be brave. What? That's exactly what you do. That's one of the first places I was trying to trick you. Okay? What do people who are not ready for this want to do right here? Yeah, they want to multiply 3 times 4, right? But we know because of order of operations, we can't multiply before we take care of exponents, can we? That means I have to divide by 3. You guys just made me so happy. Yay. 4 to the 2x power equals 5. Is the base isolated? Yes. Right? I know there's a 2 in the exponent. I didn't ask if the exponent was isolated. I asked if the base was isolated. Is there being anything added, subtracted, multiplied, or divided to the base? No. So it is by itself now, right? So if it's by itself, where do we want to go now? Logarithmic form. So log base. Be brave. Yes. Of 5 equals 2x. Can I just put log base 4 of 5 and hit enter and that be the answer? No. What am I going to have to do before I actually get the answer? Yeah, absolutely. But here's the deal. I don't remember if it makes a difference on this problem. Let me check real quick. Log base 4 of 5 is that, okay, which would be 1.161 if I rounded too early. I don't want to round too early, okay? I need to divide this by 2 before I try to round. 0.580. That's what x equals. If I try to round here and then divide by 2, I might be off by a decimal point or 2 in the third place. My third place value, tenths, hundredths, thousandths, and my thousandths place value, I might be off. I don't want to be off. I want to get the correct rounded answer. Does that make sense? Any questions? You think you can handle any of these that I throw your way? No, you're supposed to say, of course. Yeah? Okay, so what I want you to do is on the pink page that I gave you, do the 3 that I didn't do. Okay, so 2, 4, and 6. And on the white page I gave you, called Solving Logarithmic Equations, I would like you to do multiples of 3. Because sometimes doing evens are just boring. What do I mean by multiples of 3? What are we going to start on? 3, and then, and so on. You got it? Any questions?